Today I'll be going over 10.2, which is use combinations and the binomial theorem. Combination is a selection of R objects from a group of N objects where the order is not important. So that's the difference between combinations and permutations. For combination, the order is not important, and for permutations it is. Here's the equation for combination. NCR is n factorial over n minus r factorial times r factorial. So in the first three examples, we're going to find the number of combinations, and we can plug it into this equation here. So that'll be 10 factorial over 10 minus 3 factorial times 3 factorial, which is 10 factorial over 7 factorial times 3 factorial. So when we write out 10 factorial, we can stop at 7, so that can cancel out with the 7 factorial in the denominator. And that means we'll have to write out 3 factorial. So that'll be 3 times 2 times 1. Then I'm going to see if I can simplify any of them. So 3 and 9 I can simplify to 3, and 2 and 8 I can simplify to 4. So when you're finding the number, that'll be 10 times 3 times 4, which is 120. Number 2, we have 8c2, so that'll be 8 factorial over 8 minus 2 factorial times 2 factorial. 8 minus 2 is 6. And when we write out 8 factorial, I'm going to stop at 6 factorial and write out 2 factorial. So that's 2 times 1. So these 6 factorial will cancel out, and we can simplify 8 and 2, and that'll become 4. So that means we're multiplying 4 times 7, which is 28. Number 3 is 14c6. So that'll be 14 factorial over 14 minus 6 factorial times 6 factorial. And 14 minus 6 is 8. So when we write out 14 factorial, we can stop at 8. It'll be 14, 13, 12, 11, 10, 9, 8. And we'll have to write out 6 factorial. Okay, so the 8 factorial will cancel out, and then we can see if we can simplify anything. So 6 and 12, that'll become 2. 5 and 10, that becomes 2. And to cancel out the 4, we have no numbers left that are multiples of 4, but 2 times 2 that we have in pink here are, they'll multiply to 4, so we can cancel out with that 4 in the denominator. 9 and 3, that'll become 3. And 2 and 14, that'll become 7. So that means we're multiplying 7 times 13 times 11 times 3. And we'll get 3003. Okay, next section we're going to be looking at cards. We're finding the number of possible 5 card hands that contain the cards specified. Number 4 has a typo. It should say kings. Okay, so in a deck of cards, there are 4 kings, and of those 4 kings, we want to choose all 4 of them. So this part is here. Then we have the word and whenever you see the word and, that means to multiply. And then it says one other card. So there are 4 kings in a deck of cards and 52 cards total, so there's 48 other cards, and of those 48 I want to choose one of them. So then you can plug this into your calculator and you'll get 48 as the answer. Number 5, we want to pick 5 hearts or 5 diamonds. So let's start with 5 hearts. In a deck of cards, there are 13 hearts, and of those 13 hearts, we want to pick 5 of them, or choose 5 of them. And then we have the word or, so that means plus. And then it says 5 diamonds. And in a deck of cards, there are 13 diamonds, and of those 13 diamonds, we want to choose 5 of them. So the equation would be 13c5 plus 13c5. And that'll be 2,574. Number 6, at most 1 spade. So we're picking 5 cards total. And if we're picking at most 1 spade, that means we could pick 1 spade or 0 spades. But since it's 5 cards total, that means we have to have other cards. So we could have 1 spade and 4 other cards, or 0 spades and 5 other cards, since the total has to be 5. Okay, so let's start with this one here. It says 1 spade. There are 13 spades in a deck of cards, and of those 13, we want to choose 1 of them. Then we see the word and, so that means to multiply. And we want to pick 4 other cards. So other cards means cards that are not spades. There's 52 cards in a deck, and 13 of them are spades, so that means there's 39 that are other cards. And of those 39 cards, we want to pick 4 of them. Then the word or means to add. And then it says 0 spades and 5 other cards. So in a deck of cards, there are 13 spades, and we don't want any of them, so we want to choose 0. And that means to multiply 5 other cards. So again, there's going to be 39 other cards, and of those 39, we want to choose 5 of them. So once we multiply and add these together, we'll get 1,645,020. Okay, next we have Pascal's triangle. So on the left, the n values are the exponents. And in the table in pink, or in the triangle in pink, this is Pascal's triangle. So you can add as many rows as you want, and in order to figure out what the next row is going to be, you add the 2 numbers to the left and right of it, and the ends are always going to be 1. Hopefully that makes sense. But let me just show you. So 1 plus 1 is 2, 1 plus 2 is 3, and 2 plus 1 is 3. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And for n equals 5, it's going to start with a 1. And then we're going to add these 2. So 1 plus 4 is 5. Then we're going to add the next 2. 4 plus 6 is 10. Add the next 2. 6 plus 4 is also 10. And then 4 plus 1 is 5. And it's going to end in a 1. So the ends, the far left and the far right, will always be 1s, and then for the middle numbers you can add from the row before it. And you can keep doing this as many times as you want. So the purpose of the triangle is to give you the coefficients of a binomial expansion. And the first, or the power of the first, is going to go down, and the power of the second is going to go up. Okay, I'll explain that a little more when we do an example. So for number 7, we want to use Pascal's triangle to write the binomial expansion. and it is x plus 3 to the 4th power. So this exponent here tells you what the n value. So that means we're going to look at n equals 4. So the numbers in the triangle give you the coefficient. So the first one's 1. So we're going to start with 1. And the first term in the binomial is x. And you'll always start with the exponent that matches the exponent for the problem. So it'll be x to the 4th. Then our second term in the binomial is 3, and that's always going to start at 0. So for the first term, it's always going to match the exponent, and for the second term, it'll always be 0. Okay, next we're going to look at our triangle again, so it's at 4. And this time, the exponent of the first term, x, is going to go down, so it's going to go down to 3. And the exponent of the second is going to go up. So it goes up to 1. Then we look at our table again, or our triangle again. Next one is 6. Then we have x squared and 3 squared. And then for the next one, that'll be 4. And that'll be x to the first power, 3 to the 3rd. And the last one is 1. So it'll be x to the 0 power and 3 to the 4th. So if we look at all of the exponents for x, it went from 4, 3, 2, 1, and 0. And if we look at the exponents for the second term, b, or 3, that went up. So 0, 1, 2, 3, and 4. Next, we're just going to simplify all this. So that'll be x to the 4th times 1, since 3 to 0 power is 1. 4x cubed times 3 plus 6x squared times 9 plus 4x times 27 and plus 1 times 81. And then we'll want to simplify this, so that'll be x to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. Okay, for number 8, we have 2a plus b minus 2 squared to the 5th power. So this time our exponent is 5, so we're going to look at the 5th row. So for the first coefficient, we're going to start at 1. So we have 1 and then 2a to the 5th, so it's going to match the exponent for the problem, and negative b squared to the 0. Next is 5, 2a to the 4th, negative b squared to the 1st. Next is 10, 2a to the 3rd, negative b squared to the 2nd. Next is another 10, so 2a squared times negative b squared cubed plus 5, 2a to the 1st, negative b squared to the 4th, and then the last one is a 1, so plus 1, 2a to the 0, and negative b squared to the 5th. Okay, next we're going to multiply out all the exponents, so that would be 32a to the 5th times 1 plus 5 times 16a to the 4th times negative b squared plus 10 times 8a cubed times b to the 4th plus 10 times 4a squared times negative b to the 6th plus 5 times 2a times b to the 8th, and then plus 1 times negative b to the 10th. Okay, and then next we're just going to multiply and simplify what we can. So that'll be 32a to the 5th minus 80a to the 4th b squared plus 80a cubed b to the 4th minus 40a squared b to the 6th plus 10ab to the 8th minus b to the 10th. Okay, next is the binomial theorem. There was a typo, so let me fix that really quick. But the binomial theorem is very similar to the Pascal's triangle. It's just used more when the exponent is really big, so you don't have to keep creating rows. And you can just plug it into the binomial theorem. So for any integer n, the binomial expansion of a plus b to the n power is a plus b to the n power equals nc0 times a to the n b to the 0 plus nc1 a to the n minus 1 b to the 1 and all the way to ncn a to the 0 b to the n. So for a and b, it's very similar to what we did in Pascal's triangle, and the coefficients we're getting from the combination instead of from the triangle. So here is the first one, a plus 3b to the 4th. So our exponent is 4, so that means we're going to start with 4c0. And then a to the 4th times 3b to the 0. Next would be 4c1, a cubed, 3b to the 1st, plus 4c2, a squared, 3b squared, plus 4c3, a times 3b to the 3rd, and then the last one is 4c4, a to the 0, 3b to the 4th. So then you can use a calculator to figure out these here. Oh, let me use pink. So we can use a calculator to find these combinations. Or you could also use Pascal's triangle. It's going to be the same thing. But again, binomial theorem is used more for big exponents. So that's going to be 1 times a to the 4th times 1 plus 4 a cubed times 3b plus 6 a squared times 9b squared plus 4 a times 27b cubed and then plus 1 times 1 times 81b to the 4th. So these numbers that I got in the front are from plugging that into a calculator, plugging in the combination into a calculator. Okay, so once you simplify it, you'll get a to the 4th plus 12a cubed, b plus 54a squared b squared plus 108ab cubed plus 81b to the 4th. Okay, and then for number 10, you would do the same thing. I'm going to skip that one because this video is getting a little long. And I want to do the last two before this video is like 30 minutes. Okay, so number 11, it says TCHS Rampage has an editor-in-chief and an assistant editor-in-chief. The staff of the newspaper has 12 students. Decide whether the problem requires combinations or permutations to find the answer. In how many ways can students be chosen for the two positions? So if you ever see a title or like a name for a position, then it's going to be permutation. And in this, we're picking an editor-in-chief and assistant editor-in-chief. So that means this is going to be a permutation. So that means we're going to have a big P in the middle, and we have to figure out N and R. So there are 12 students, And of those 12, we want to pick 2. So the setup would be 12p2. And you would get 132. Okay, number 12. A secret admirer wants to buy Bella a bouquet. The florist has 18 types of flowers and Bella wants exactly 3 types of flowers. How many different combinations of flowers can the secret admirer choose from? So in this case, it doesn't really matter what order they pick the flowers. They could pick like daisies and then roses and then sunflowers or any mixture of those. So this is going to be a combination. So we're going to have a C in the middle, and there are 18 options of flowers, and we want to choose exactly 3. So the setup would be 18C3, and you would get 816.